Did LeBron James choke in the playoffs? To investigate what kinds of variability in performance we can expect because of random chance, we will conduct a simulation. Although it is impossible to actually know LeBron's ability, for now we will assume his ability to make three-point shots in the playoffs is 31.5%, which was his actual three-point shooting percentage in the regular season. We will simulate the 70 shots he took in the playoffs, assuming he has a 31.5% chance of making each shot. Since a coin does not have a 31.5% chance of landing on heads, we have to come up with another way to simulate the shots. So one way to do this is to make a spinner. The spinner shown has a 31.5% section labeled made shot and 68.5% labeled missed shot. To simulate his playoff performance, we will spin the spinner 70 times and keep track of the number of shots made. A Y represents a made shot and an N represents a missed shot. In the simulated playoffs, LeBron made 25 of 70 three-point shots, which represents a performance of 35.7%. This performance was slightly better than expected since his ability was assumed to be 31.5%. Of course, the result is just one possible performance for a shooter with a 31.5% ability to make three-pointers. To see what other performances are possible, we will conduct 99 more sets of 70 spins. Each dot in the dot plot below represents the performance in a series of 70 shots for a 31.5% shooter. In other words, each dot represents what could have happened in the 2008 playoffs if LeBron's ability stayed the same as in the regular season. In the graph above, the dots that are red represent sets of 70 simulated shots where LeBron's performance was 25.7%, which was his actual performance in the 2008 playoffs, or some of them are less. Since 23 of the 100 dots are red, we can conclude that shooting 25.7% is not unusual for a shooter with the ability of 31.5%. We would expect him to shoot the same, or in some cases worse, in about 23 of every 100 playoff appearances simply by random chance, even if his ability remained constant at 31.5%. Since it is not possible to rule out random chance, we do not have convincing evidence that LeBron's ability to shoot three-pointers was lower in the playoffs. When you're making conclusions, you need to be very careful that even if it looks like there's convincing evidence, you cannot say why. You can never rule out random chance if it is within the realm of possibility, if it is within the realm of your simulation. If an athlete's ability really does decrease, it's much easier to rule out the random chance, but you still can't say exactly what caused it. If you look at some different scenarios, one where he takes 7 three-point shots in the playoffs and one where he takes 700 three-point shots, you'll see the simulations come out much differently. For the first scenario, we have the 7 shots, and you'll see that there he has a fairly good proportion of shots that are less than his actual performance. Whereas when he takes 700 shots, you'll see that he doesn't have any. Do catchers wear out? A common claim in baseball is that catchers tend to wear down as the season progresses because of the physical demands of the position. This claim seems to have even more validity for catchers who rarely get time off and who play in warm, humid climates. In 1996, Ivan Rodriguez of the Texas Rangers exemplified these conditions. He played in 153 of his team's 162 games, which is a very high proportion for a catcher. And the heat and humidity in the Dallas area can be extremely high for weeks at a time. It would seem reasonable to expect that his ability to hit would decrease toward the end of such a physically challenging season. During the season's first 5 months, April to August, Ivan Rodriguez had a batting average of .317. In the last month, his batting average was only .214. So the first thing we want to do is to make a bar chart to compare his performances in the first 5 months with that of the last month. So as you can see, April to August is much higher for the batting average than September. When it asks you to describe what you see, that is all you have to put, but please use complete sentences. Suppose Rodriguez's ability to get a hit in 1996 is actually .317. Explain what ability means in this context. If Rodriguez were to keep hitting in the same conditions as 1996 season indefinitely, he would get hits in about 31.7% of his at-bats. The key words in this are the same conditions and indefinitely. Make sure you always have those in this type of question. Assuming that Rodriguez's ability to get a hit is .317, describe how to use the spinner to simulate his number of hits he gets in the 103 September at-bats. So you're going to create a spinner with 31.7% labeled hit and 68.3% labeled miss. Spin it 103 times, keeping track of how many times it lands on hit. Plot that on a dot plot and repeat many times. So they did 100 trials of the simulation, and the number of hits was recorded for each trial. So if you look at the dot plot, you'll see it goes from 23 all the way up to about 48. The dot plot shows the possible performance Rodriguez could have, assuming his ability is .317. Based on the results, does his actual performance of 22 hits in 103 at-bats provide convincing evidence that his ability to get hits decreased? Well, 22 was not within the range of the simulation. So the answer is yes. We do have convincing evidence that his ability decreased because 22 is not in the range of the simulation. If we conclude that his ability did go down in September, can we say that wear and tear is the cause of the decline? These are really simple to answer. Unless it is an experiment, the answer is always going to be no, there may be other factors. Okay, one last example that's not sports related. So Nate Silver is one of ESPN's newest analysts, but he's also famous for making political predictions. So he claimed that the Weather Channel deliberately makes poor predictions in some instances. But people tend to notice a failure to predict rain more than they do if they predict rain and it doesn't rain. I mean, you would rather go outside and have a sunny day when you expected rain than have rain when you expected a sunny day, right? So when the Weather Channel says there's a 20% chance of rain, it should actually rain 20% of the time. Texas A&M did a study and found that out of 113 days that had a 20% chance of rain, it only rained 6 times. So the first thing we're going to do is to make a graph to compare the expected percentage of rainy days to the actual percentage. So the percentage of rainy days would be 20% predicted. The actual would be 6 divided by 113, which is just over 5%. So you can see that the percent of predicted days is much higher than the actual. Make sure that you do not skip the explain or the describe part of questions. They're very easy to overlook. Assuming that it actually rains on 20% of all days when there's a 20% chance of rain, describe how to use a spinner to simulate the number of rainy days. So we're going to create a spinner with 20% labeled rain and 80% labeled no rain. Spin the spinner 113 times, count the number of times it lands on rain, plot it on a dot plot, and repeat many times. You do not have to draw a spinner, and I will never ask you to make one and actually spin it that many times. 100 trials of the simulation described above were carried out, and the number of rainy days was recorded for each trial in the dot plot. Describe what information is provided by the dot plot. So the dot plot shows the possible number of days of rain, assuming a 20% chance of rain. Based on the results of the simulation, is there convincing evidence that the Weather Channel deliberately makes mistakes? Well, the simulations go from 14 to 35. The actual result was 6. So the answer is yes. 6 is not within the range of the simulation. If it had rained 18 of the 113 days, would your conclusion be different? If you look back at the simulation, 18 is within the range of numbers. So your conclusion would be different because 18 is in the range of the simulation.